Hi everybody, in this video we're going to continue with graphing linear equations in two variables, and we're going to focus on kind of some special cases where we have vertical and horizontal lines. And I want to show you what those look like. So first of all, a vertical line is a line that goes straight up and down. So instead of your graph being slanted or tilted like we're used to seeing, it's going to be perfectly straight up and down. And that happens in a very specific case. It happens when your equation looks like x equals a number. Okay? So for example, something like x equals 4 or x equals -1/2. So what's happening here is that you have no y variable. I guess it does exist there, it just has a 0 being multiplied with it. So it's just not really showing. So when you have something like that, you do have a vertical line, and they're actually pretty easy to graph. So I'm going to do the two examples that I have here. So I'm going to do x equals 4 first. So all you need to do is find 4 on your x-axis, and then you draw a vertical line straight through it. And that's it. That is your graph when you have something without a y variable. Now, I do want to point out that what's happening here is that all x values are 4. So you're still running through an infinite number of points, it's just that all the x values are 4. So for instance, the 0.40 is the one I plotted, but the 0.41 is also there, as is 42, or 3, etc. So you still have all these points there. It's just very quick to graph. So if you're graphing on technology and you do need to show two different points, just click the one on the axis and click any other point above or below it, and it will make that vertical line for you. Let's say I want to do x equals -1/2. So again, you're going to find -1/2 on the axis, which is going to be right here between the 0 and the -1. And then you're going to just draw, to really take out a ruler here, a vertical line straight up and down. And again, all those points are still there. So this is the point -1/2, 0, and then this would be the point -1/2, 1, etc. So you still have infinite many points. I just don't have to go through a whole solving procedure to graph here. It's pretty straightforward. Now, as a little tip here, sometimes you could have examples that maybe don't appear to be vertical right away. So for instance, let's say I have something like x minus 5 equals 4. You're probably looking at that like, wait, what? And I said to graph this. Well, your reaction may be to start plugging in values here, but I actually don't see a y. So basically the y has a 0 multiplied with it, so it's kind of hidden away. So what you could do in an example like this is you can just solve for x like you normally would. And then now we put it in a form where we can see that this is a vertical line. Okay, so now we can graph it. I can see it's x equals 9. I can find 9 on my axis and put that vertical line through. So you do want to be careful if you see something that's not in the simplest form right away. But again, notice that it has no y, and that's key. If it has a y and an x, it's some sort of tilted or slanted line. It's not going to be one of these exceptions. So these are our exception lines. And the other one is our horizontal. So your horizontal lines go perfectly left to right. And what you're going to notice here is they look like this. Y equals, I'll just use B here. So some number B. So for instance, y equals -3 or y equals 2.4. So what you're going to do there so here, 1, 2, 3, 4, -1, 2, etc. So all those points are still on your axes. Then here you have 1, 2, 3, 4, etc. -1, -2, -3, -4, etc. So what you're going to do is the same idea, but the opposite direction. So you're going to find y equals -3 on your y-axis. And then you're going to draw a horizontal line right through it. So what happens here is that all y values are -3 on this line. So for instance, this point right here is 0, -3. You know, this point right here is x is -2, y is still -3. Or this point right here, if you look, x is 2 and y is still -3. So you do have infinitely many points. They're just going to be all flat and stay the same along the way. You can do decimals, fractions as well here. So I'll just estimate 2.4, so 2 4/10. So I find it on the y-axis. So it's going to be maybe not quite halfway, but almost. And then I would just draw my horizontal line right through. And really, you should take out a ruler there to draw that if you're not good at drawing straight lines, okay? So here we have a point, that would be 0, 2.4. But again, all these other points are on there too, right? Here's the point, -1, 2.4, etc. So that y value stays consistent. And just like before, you do need to be a little bit careful sometimes. So maybe it's given to you like 2y is equal to 4. And it says to graph. And you're like, oh, but hey, this kind of looks like a regular equation. But you notice that there is no x. So here, there is no x. So what you do is you're going to go ahead and solve this. And then now I can see that I have a horizontal line. So most examples I think will probably be given to you in a form that's already simplified, but you do want to be careful if it says to graph and you go to start plugging things in, you're like, wait, this doesn't make sense, and you're noticing one of the variables is missing, then you have either a vertical or horizontal line. And you want to be careful not to mix them up. Students mix these up all the time. So horizontal lines are the y equals. The way I remember it is I kind of think a y looks like an upside down lowercase h. So that's how I remember it. If I go back to my vertical lines, I remember because an X almost looks like two V's stuck together, right? You can kind of see a V here and then a V on the bottom. So I think the X reminds me of vertical. So that's how I remember it. But you do want to make sure you don't mix them up. That's probably one of the biggest mistakes I see is students recognize that they have some sort of special line here, but they're graphing the wrong one.